Okay. So BWC, why is BWC important, right? Because before we were talking about how your nutrients, or rather N specifically, is heavily, heavily affected by the presence or lack thereof of moisture. So if there is a lot of moisture, right, you will have leaching, runoff. It'll carry away your nutrients that you're applying. If you don't have enough, then the plants, even though there may be nutrients in the soil, the plants won't have access to them because the plant needs that medium of water for it to get to the things that it needs. So, so the sensor, the Acropex sensor, is actually measuring something called the bulk electrical conductivity. So when they talk about bulk electrical conductivity, that's referring to the solid physical soil aggregates, the actual pore water, and the air even of the soil. Because believe it or not, air has its own EC value too. It's very low, very, very low. But at the same time, it actually has it because vapors actually have sometimes ions in them. But the thing is that that's all well and good. But as I said before, it's not really agronomically useful. Why? Because the plant doesn't interact with the soil, the physical soil directly. It interacts with the soil via the pore water. So even though the sensor is only measuring the EC, the bulk electrical conductivity itself, we have an algorithm that uses the volumetric water content or the moisture. And with a lot of testing, I mean, these are, if you've seen these before, these are suction lysimeters. What we did is that we would take these lysimeters, they're not like a lysimeter you would necessarily know, but you would stick them in the ground and then you would apply a vacuum and then you'd suck out the actual pore water in the soil and you would test the electrical conductivity of that. And then we were able to create an algorithm and that actually is able to convert the bulk electrical conductivity, which is not agronomically useful, into the pore water EC. And as I said, this is the EC that the plant is actually feeling. So if the EC is really high, then the plant is going to have issues because it's going to be too saline, or maybe too saline. And then if it's too low, then the plant doesn't have access to nutrients that it needs. Lastly, because different soils, though, have different saturations, right? So it's somewhat difficult to compare the nutrient loads of different soils. So there's a common test called the EC saturated paste, where you take a soil and then you dry it out and then you add a certain amount of water to it and then you convert it. And then that way it sort of it normalizes the soil for its ability to hold water. Because if you think about it like this way, if you take a sponge, and let's say a soil is kind of like a sponge. I always think of soil like a sponge, actually. Because if you take a sponge and you only partially wet it, right? You're not going to dissolve, and if there's salts in that sponge, you're not going to actually see all the salts in your solution, right? Because the sponge is not fully wet. But if you get the sponge or soil completely wet, right, up to saturation, that means every single ion that's there, that's going into solution. And then we're going to actually really be able to see the nutrient load that that the soil has available. So it's a way of normalizing and comparing the EC values between different soils. So we provide EC saturated paste. We call it a salinity graph in the application. You can access this by going to the sensor graphs. Unlike the others I just showed you before, everything else is on a half-hourly resolution. We provide this on a daily resolution because it doesn't change that much, and it just gives you a little bit more stability. It's easier to read when it's not bouncing up and down because of all the different like temperature and noise that sometimes creeps in to the signal. So it's a daily value, and again, it shouldn't necessarily change that much from day to day. So as I said before, if you go to your summary for a field, you'll go to, oh, I can't, oh, I guess, is there where's the pointer thing? Do you have the pointer thing? No, that's okay. I don't need it. So if you go to the summary, right, and then you hit sensor data, right, this is not your typical screen. It's okay. We don't need it. That's okay. Oh, no. Okay. He'll find out tonight, I'm sure. So if we go to the sensor data tab, you'll see typically what you'll see the profile sum, all those things. And then you see on the bottom right, that's the electrical conductivity. That's the EC pore water, as I said before. That's what we show by default in the application. And so this is a typical EC pore water graph. It responds to irrigations, and it also it responds to the it responds to wetting events because oftentimes when you irrigate, there will be salts in solution too, right? And so sometimes even though you would expect your soil to, you use the water to wash out the ions, let's say, or the salts, there's salts in the water sometimes too. Oftentimes, in Israel, like if you go to a date palm field, I was saying this before, they use effluent, right? And it stinks to high hell. Like it's really, and the EC there is crazy high, but the date palms like it. So, but we could see that we could see that track. We could see that the EC actually increases for every irrigation, and oftentimes they actually have to double the amount that they would normally irrigate just to get a decent washout of salts. This is just an image of the EC saturated paste. We provide it on each level for each depth individually. You could also see that on the top, there's a threshold value. If you don't provide a crop, then we don't give you one really. We just get an arbitrary number at the top. But if you provide one, then we'll have it is a crop specific threshold because obviously certain crops are more sensitive to salinity. And salinity, I just want to say, salinity refers to the amount of salts, but it doesn't refer to the amount of sodium. That's a whole other thing. I just want to make sure. That's called sodicity. Yes. Yeah. Yeah. See this on the V4. The cortex? Absolutely. 1000%. That's the big work that they're doing back in Israel, actually. Hmm. Yeah. All of these thresholds, these I don't want to say set points because they're not. You don't want to get to them. Yeah, like a notification. But yeah, you could set these. I don't think you could see it on the top right actually, where it says set EC. The very very top right, it's hard to see. It says set EC threshold. You could set one manually, but if you, like I said, if you have a crop, I've done a lot of research on all these crops. I have each of the crops that we have in our system has an EC threshold already set. So if we go back to the summary screen, now we're going to go to, if you see the nutrition tab on the left, it's underneath disease at the bottom. Okay, if we open it up, first things we see is the EC saturated paste of the first sensor depth. Okay, it'll also give you a little bit of a like I said before, right? There's a setting where it says adequate here because it's not too high. If your EC is too high, then you'll see a saying like a warning, and it'll give you a remark about that, and it'll be in all red. And so you should probably take action and probably irrigate. And underneath that directly, you'll see something called leaching data. Okay, and then it gives you a little bit of a couple of sentences about what's driving the leaching algorithm, how we detect leaching, right? And then underneath that directly is a leaching calendar. So, and you can go back and forth in history. By default, it just shows you the past 30 days. And you would see it on the calendar itself. And it also tells you 4 days since the last leaching, and it'll tell you also how many leaching events there have been in the last month. But like as I said, you can go back and forth in time. And I forgot to put this on the slides actually, is that it is? One second, technical difficulty. No, I don't see it. It's weird. No? Whatever. So, what was I saying? Oh yeah, I forgot to put this on the slide also, but when you first log into the CropX app, you'll see an overview page. And it'll actually give you all of the fields that have experienced leaching in the past day, past 7 days, or the past month. You can decide whichever one you want. By default, it's the past day because we don't want to freak people out when they log into the app. But in either case, That's something that it'll say end leaching. It's like a card. Forgive me for not putting that up here. And right underneath that says leaching history. You'll see it says leaching factors. And that's a little pop-up graph. If you press it, and what it'll do, it shows you the moisture, which is in blue, of the topmost sensor. And then it'll give you the EC of the sensor at the bottom depth. And the idea is, and this is sort of just an example of how the leaching algorithm works. What it does is it's looking for wetting events, right? And we were talking about this a lot yesterday, how and thankfully we have a really accurate wetting detector now. And so what we use that for is we say, okay, have we seen any, given there's a wetting event in a certain amount of time, have we seen any sustained or consistent, have we seen drops in the electrical conductivity? And then we say, we evaluate that, and then we have an algorithm, right, that processes it and evaluates if there was a leaching event or not. So when you think of leaching, right, obviously we think of moisture and we think of EC, but the algorithm is specifically only looking for when there is a significant wetting event, not just like a little drizzle either. So there's thresholds for all of those things. Another thing, right underneath the leaching factors is another little, sometimes it's hard to see, but you can actually add fertilization records directly from the nutrition tab. You can also do it itself, but this is sort of what it looks like. You open it up, and here you can thing too. You can add irrigations that you manually applied. You can manually apply irrigations, spraying events, scouting. But in any case, you could have fertilization applications. All you do is you go to your product type. We have a bunch of them too. And if there's one that's missing, just let us know. I'll add it, and happily, no big deal. I can do it directly by myself. And then you'll put down your flat rate, how much you put down, and then whether or not the amount you put down was the amount of product or the amount of N you put down. Okay. And then underneath that, you'll see that it's already chosen the field that we already wanted to do it for. And then you put down the date. And then as soon as you add that, you'll see that you'll see the fertilizer. It's all good. You'll see the fertilization tasks already updated with the amount of N that you put down. Okay, and then if we go, and then you could add more applications, but then if you go to the agenda, you'll see that it's put it up there already. And what I really like about this, why I think this is really cool actually, is that if we didn't have to say have a sensor, we didn't have the sensor graph right here in front of us. What's really nice about this is that you see, okay, I put a fertilization event on a cert today, and then I look at the agenda and I see, oh wow, there's a forecast for rain next week. Maybe I shouldn't have put that fertilization down. I shouldn't have applied. So these are sort of, it just helps, it's good for like understanding what you have done and what you want to do. And you could also do comparisons in the past. So, and also on the top right, you can see this is plus, and you can, that green button over there, you could add from direct in the agenda as well. So then my favorite part actually of all of this is like, I think this is so cool. I get giddy every time I see this actually, because I really like, maps. I like pictures, like other people, I guess. And I know Nick talked about this a lot, but we actually have variable rate for everything, not just irrigation. We could have variable rate N and sowing and all sorts of things. And this is just a nice field that we have in the Netherlands. And so what we do here is that, okay, we want to create variable rate, right, for our field. Well, before we do that, we need to have management zones, right? We have to figure out, how do we want to apply it? What are our zones? We want to do variable rate, but I don't know, what should I do? So we give you guys options of how to create these VRA maps. So if I go and click create VRA map on the bottom, I already did it. What'll happen is it'll give me some options. It says, okay, let's create your zone map first, right? And so you could base this as off of lots of things. You could base it off elevation, so any topographical features. Obviously, that's really important, right, for like fertilization especially. And then also you could use satellite data. And if you do satellite data, we have different actually indices that you can use. So you could use typical NDVI, you can use SAVI, or you could use the productivity map, which is actually, it's a that looks at the productivity of your field over the past 5 years. And I actually think it's really cool and it's very powerful because it's sort of the issue with the NDVI sometimes is that you may have a bad image. So when you're choosing the satellite imagery, just make sure you choose a day because it's going to then prompt you for like, oh, what image date do you want to base it off of? And so that's something that it's important to consider. And the coolest one, in my opinion, is the machine data one actually, because if you choose that, it'll ask you about, okay, which data set do you want to do? Oh, sorry. We're using Sentinel but we could use Landsat too. We're getting that data also, actually. Yes. Yeah. Yeah, and that's a great point, John, because and even though it says machine data, people think of tractors and things like that. You can put really any image there, actually. Just one image. You could put an image. I mean, that's an interesting point to make, actually. That's very cool, actually. But the productivity map, actually, that's sort of what it's trying to answer, is it's using lots of images over time and averaging out. Um, but it doesn't have to be necessarily just imagery data, right? It could be maps, EM maps, EC maps, whatever you have, whatever imagery you have, drone imagery and things like that. You can use that to create your management zones as well. Okay. Okay. Yeah, absolutely. Absolutely. I would. No, absolutely. Yes. Yeah, yeah. That's right. Underneath Savvy, let me, years. 5 years of imagery data. Yeah. So it picks it for you. It takes 5 years worth of. No, it doesn't take the cloud cover days. We filter those out. We actually filter those out automatically in the app. When you look at the NDVI graph and the field data, you don't act, and when you look at the actual curve, it doesn't take into account any cloudy days. Okay, I understand. But so that's the as a data science. Oh, better, Mike. Oh, that's nice. Okay, much better. Um, so as a data scientist, I really believe in the power of a lot of data. Data will, even though you have one image that maybe is bad, over 5 years with of imagery, that'll get canceled out. It won't affect your measure. It won't affect it too much. I can guarantee you, you know, 5 years of imagery is a lot. Yes, John. Mhm.
Test one, two. Test one, two.
You're fine. Okay. So, um, as I was saying, also, uh, you have machine data. You could use whichever data set you want to do, also base it off of that. And then after you've selected the amount of zones that you want to create, then it'll create the map for you. Okay. And then it'll show you the distribution of each sort of zone and how many acres each of them can cover. And then when you are actually creating your VRA map, what you do is that you'll give it like a min rate and a max rate, and then it'll distribute it for you across those zones. Okay, and then when you go and then you hit continue, and then what will happen is that you'll go to the next screen. Will be like, okay, I could download this VR. I think it died. Oh, okay, it works again. I could download the VRA map, or I could send it right away to like John Deere, um, or a partner connection. Yeah, a Viper. Yeah, let's. I don't see it here, but I'm sure you could just download the image itself and then send it there. But I'm not sure. Oh, there it is. Okay, I didn't see it. Yeah, and so as I was saying, and actually I've used this sort of tool with the variable rate stuff. Is I've used it a lot for just creating nice management zones myself. Yeah, 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 yeah. Absolutely, absolutely, totally. So yeah, and then if you see on the bottom right of that image with the management zones, right? I showed you before. It gave you not only like the amount of acreage each zone is, the rate for each zone. It's a little bit garbled because of the text that's kind of squished, but also it'll give you the actual amount to apply on the very far right. If you see it, it says in kilos, 520.97 kilos for zone one, and so forth. So you'll actually have the not just the rate, but also the absolute amount you're going to apply in that zone itself. I'm done. Sorry, I, I can't hear you. Say that again.